NeuroIS paper. Did you guys get a chance to look at it? All right. So I'm not going to do a huge review of this paper. It's really simple. Basically, this paper lays out all the different NeuroIS technologies, and it discusses barely what types of measures they can collect. And then, since this is an information systems paper, it sort of lays out 9 areas where you can possibly explore within the realm of information systems certain questions using these tools. All right, so I have done some of this work, so I thought I'd bring it to your attention. The whole point of this is to expose you to new ideas, and maybe you'll decide you want to follow through with them. Do a summer project, devote your life to it. Okay, so here are what are called psychophysiological tools. They're supposed to measure responses from your brain. So eye trackers. Okay, I brought an eye tracker today. It's in that suitcase. I might show it to you if there's time. So eye trackers can measure, depending on the type of eye tracker, you can set it up so it can capture where you're looking anywhere you are in the room. So if you have a camera attached to it, a scene camera. Or the way I use an eye tracker is I only capture where you're looking on a computer screen. It also captures like your pupil dilation. So if your eyes get wide, and when does that happen? Like if you think you're in trouble, or if you're stressed, or if you're lying, then your eyes will go, oh, and I can measure that, right? So, yeah, if it's some sort of stimulant, yeah. Well, see, that's true in the northern hemisphere. It's reversed in the southern hemisphere. That's not true. That's a joke. Yeah, we're like toilet bowls. Okay, hey, I don't think that's true at all, what you said about looking to the left, even though that's how they train cops. Yeah. Bill Clinton. Yeah, Bill. All right. So skin conductance response. So basically, if you sweat more, then you should conduct electricity better or something. So stress will, this is one of the measures in a polygraph examination. They hook you up and measure your skin conductance. All right. So the idea is if something's happening to you, you're getting stressed, you're really happy, whatever emotion, then it's going to change perhaps the results of these types of tools. I've never seen a facial electromyography or EKG. Yeah, actually, one time I told them I think I had an EKG, right? When they stick the things on you. Yeah, I had one of those. I didn't have any heart problems. I just had pulled a muscle. Okay. Then there are these brain imaging tools that maybe you guys have seen. These big machines that you stick your head in, and it maps what's going on in your brain. So basically, if you're maybe reading, if you're thinking about if you're being creative, this half of your brain will be all lit up or something like that. So maybe you want to ask a question, if someone's committing fraud, what part of their brain is activated? Okay, so you stick their head in one of these machines while they're committing fraud to get the measure you want. Okay, is that really feasible? Well, no. I mean, that's one of the weaknesses of these types of tools. I mean, they're great if you can somehow use them. Yeah, Kristen. Right. So yeah, it would be a within subjects baseline measure. So I think you would just establish a baseline for the individual before you start saying, did you kill your wife or something? Then we know the baseline, and then you see if there's a spike. Yeah, right. They ask questions that are innocuous, like what's your name, what's the color of the wall, did you kill your wife? Yeah. Yeah. I mean, yeah. So these are called countermeasures, moves and counter moves. Okay. So we have all these different tools. So what are the strengths of these types of tools? The idea is you're going to get information straight from the brain. You're not going to have to ask them if they feel stressed. You're going to know if they're stressed because you have a direct measure. So this is trying to get data that cannot be manipulated by the subject. Okay? So you can avoid certain biases. Subjectivity bias. Okay? So it's not an interview question. You're getting objective measures. Social desirability bias. It doesn't matter what you think they want you to say, or what you think they want you to feel, or what you think they want your brain to do. You can't control it, right? Or the same thing, like the demand effects. If you know what the experimenter wants, it doesn't matter as much. If you know what the experiment's about, even if you know, you can't really manipulate the results. So the paper goes on to say, well, there's some difficult to measure constructs that you can potentially get at using these types of tools. So sensitive issues like politics, wages, gender, religion, things like that. Personal issues, hidden emotions, habits. Okay. So these tools have weaknesses. So one is some of them are very costly and hard to get a hold of. As I intimated, there is some sort of an artificiality to this when you're asking them to complete tasks with this huge machine over their head or while they're laying inside of a tube. So one thing that these tools do is they generate like big data, gigabytes and gigabytes of data. And it can make the analysis much more difficult, maybe just because you need more processing power. So there are some measurement issues. So maybe you're not measuring what you think you're measuring. And subjects may act differently toward the stimuli. So maybe you have to treat subjects differently. I don't know. What was this one? Mono-operationalizational bias is saying that if you're going through all this effort, the main thing is you have one way to measure what's going on in the brain. You have this big expensive tool, you spend a lot of money. Well, is this one measure really telling you the whole story? Or would it be better if you had multiple measures to be able to, that could confirm each other? So I participated in a study as a PhD student. I was an information systems student. We did deception detection work. And we had this study where we had a polygraph examiner, and he was asking questions, and we were pointing a bunch of devices at the subject. So we had a thermal facial thermal imaging. So we had a camera pointed at their face to look for changes in temperature on their face. So what they look for there is these areas on the face that have very thin skin. So if there's blood that rushes to the head, then the temperature would change. And so our main area of interest was around what's called the periorbital region, so around the eyes. So we were looking for, but at the same time, we also had a laser Doppler vibrometer. So this is something that detects very small vibrations. And all of these are unobtrusive, so you don't attach, we didn't attach anything to our subjects. So it's this little, it's like a laser pointer. You point it at their carotid arteries, this area, and it measures any slight movement in that area. So they use that tool for manufacturing and to get precision and building auto parts. So we were just using it to measure differences in the distance between the tool and the skin. And every time there's a vibration, the distance changes, and you can measure the distance. So then you could extract from this signal respiratory patterns and I guess blood pressure and things. I never looked at the data, but I had to run the tool. We also had cameras so we could analyze gestures and facial expressions. Yeah. Thin skin, literally? Yeah. Well, yeah. Okay. I don't want to talk. I don't know all the differences between heavy set people and lightweight people, but yeah, you're right. There could be differences. Maybe we should have controlled for that. The BM. We should have had the BMI for every participant, but maybe they would have lied, or maybe they would have just been like you, muscular, and that's why they had a high BMI. So maybe there's a better measure. What else did we have pointed at them? I think that was it. But yeah, that was another tool that is a really good one that I'm interested in using someday. They didn't have here was the thermal imaging. Yeah, and plus you can buy a thermal imaging camera and hook it to your iPhone now. It's like $200, and that's really nice. So you can see if there's people behind walls, spy on people. Okay, if you like that sort of thing. Okay, so there could be difficulty interpreting the results. There could be ethical issues. So you may be getting at personally identifiable information. If you're looking at someone's brain, and maybe you're getting into mind reading. Anyway, you may find out information that the subject didn't want you to know beforehand. Right. So here's the part of the paper that kind of applies to us. So most of the paper is devoted to talking about the applications of NeuroIS to traditional IS research. So this is an AIS class. So what I want you guys to do, I know you all have a copy of the paper, right, on your computer or with you. So what we're going to do is I'm going to assign you into pairs, and you're going to take one of these areas, okay, and I'll just tell you which one. And I want you guys to think of 1 to 3 research opportunities in AIS. And if you can, talk about which tool you would use and what you would measure. Okay? All right, so I'm going to group you into pairs. So Kristen and Shuan. And your name tag's down. Kexing and Yua. Okay, you're a pair. And can you two be a pair? And you two be a pair. And are you in the class? You two in the pair? Are you in the class, Freddie? All right, you three all together. Then you two and you two, okay? Right, so what you're going to do is you're going to work on number 1, 2, and there's sections in the paper with these headings, okay? So you just have to look for that section. And within for each heading, there's also a nice little table that summarizes some of the research ideas for IS that might help you come up with ideas for AIS. Okay, so 1, 2, 3, 4, 5, 6, 7. Yeah, you're 7. Okay. Okay, you can be number 9. You're 7, 8, or 9. So you all know which section you have? Because I'm going to switch slides here in like 10 seconds. Yeah, you're number 4. So there's a section in the paper called, so what you're supposed to do is figure out how you can make an AIS research question. Yeah, AIS. I don't care about regular IS. You know. So here's your assignment. So if you look, there's a table that you should look at first for your section. Oh yeah, you saw that table. Yeah, so make sure you reference that too. It'll help you. Okay. Tiffany, are you on the first page? Oh, because you downloaded it before I updated it. So it still should have about the same stuff. You know, Miklos, I think we're the first people, the first group to discuss NeuroIS research opportunities in AIS. We're the first ones.
I was the first person to discuss how to use all it.
Well, there you go.
And he's the first person that does a research that not even his advisor understands.
So maybe one of these guys wants to write the NeuroAIS paper with me.
Good. Put them to work.
I know, that's what I'm saying, but I got to find out who's interested.
Randy is good.
Well, I'll find out when he edits this recording. Yeah. Yeah, any of the tools that are mentioned in the paper, or if you can think of something else. For example, have you seen the Wii Fit pad? It measures, you know, Wii Fit, like on the Wii, the Nintendo Wii, like it measures shifting of weight, and that's kind of related to people being nervous or something like that. Anyway, if you can think of something else, then that's fine. Yeah, go ahead then. Yeah, whatever. As long as it helps you to get at your answering the question that you've posed. That's right. Yeah. What's that? Oh, which one? Designing organizational incentives that are based on the functionality of the human body. Um, do an accounting. I think what it's saying is providing incentives that either make people happy, I don't know, make their theory of the mind. I don't know theory of the mind, but align. I think what it's saying is, every organization has to set organizational incentives. So why not align them with, or study how those incentives affect the human mind, or something like that? Like, are they truly incentives? Are they? I mean, that's just my quick interpretation. Is there something else in the text? Yeah, but I don't expect everyone to have great ideas, but maybe you will have a great idea. Don't feel bad if you don't, though. if you, but you'll have to tell everyone your idea anyway. Yeah, they're engaged. For the first time, they're reading the paper. We have two, but they're the same one.
You bought it or is it owned by?
It's Rutgers, yeah. Well, I bought it with Rutgers money when I first got here.
Can I use it?
Yeah. Co-author.
Do the software as well, like
What's that?
software, like keep track of,
Oh, software?
software.
Yeah, it comes with software. So what I did is I created this little experiment, and then I made some sort of a GUI interface, and I made that in Python, and then I can make calls to the eye tracker, like when to start it, or when they push a button in my program, when to add that to the data that it records. It'll record a button press too. It's pretty easy once you figure it out. It's hard to figure it out at first, but
Okay,
yeah.
there's software. They do have software. Like I know that the eye tracker. Do they provide an API which I can incorporate in my software? So if I develop, what I'm trying to do.
I mean, there is an API. Yeah.
They do have API.
Yeah.
So I can use it. I can use their software.
Yeah.
Capture.
Yeah. But I'm on a new eye tracker.
Does it works well or?
It works okay.
What I'm thinking is, like I'm thinking about doing that experimental design stuff. Like I provide students reading a bunch of the data set. One is graph, one is a table, one is other representations, and see how use this information when they have as
Yeah. I
some of them
understand.
are easy ones, some of them are difficult ones, which means they have to use all of them.
Mm-hmm.
And some students may start with the table, some start with the graph.
Okay, you want to do that? It's going to be a NeuroAIS. A paper like this one.
It's not a new AIS. We just borrowing their tools. We do the same thing.
No, but are you saying we do a paper for NeuroIS?
We can put it. We can cast that whole paper as NeuroAIS.
Yeah.
Innovation, kind of
So-
out of the box idea, and Dan will publish it for sure. I'd be very surprised if it's not.
Okay. Will you take notes of what the students say if they have good ideas?
Sure.
Because one part of the paper would probably be what are the applications to AIS, right? So I'm going to go talk to them right now. Do any of you guys need more time? Or you want to run it? Well, can you run it by me in class? Yeah. How are you guys? Do you have one idea? would you benefit from a couple more minutes? Okay, one more minute. I'm not sure this is going to work. How many things need to be plugged in? Just two. Oh, man. Well, okay. Kristen's group? Okay. Can you stand? Yeah. So everyone listen to Kristen and Shuan's idea. Oh, sorry. Can you tell me the area you were looking at? Yeah. So number one, right? Yeah.
System. So we were thinking of using any of the brain imaging tools, maybe like the fMRI or one of the others. I don't really know the specifics of what they do, but one that can measure kind of the brain activations associated with perceived usefulness. So like in the context of like some sort of automated accounting system, maybe help identify like which parts of that like automation process, like in terms of their daily use, cause the end user the most distress, and use that to kind of improve the database or the automation process, um, and like increase the utility of the accounting system.
Okay. Go ahead. You're working on number two, right?
Julie, we cannot hear you at all. A little bit louder, like screaming.
So what tool would you use to measure cognitive overload? fMRI. Yeah, I understand. Very good. Thanks.
So ours
Oh,
was
but you have to also stand.
on the
No,
chair.
chair
Ours was
optional.
annotate the number three, which is kind of challenging to relate to
Yeah.
accounting, which is this online consumer. But we thought about if a company, let's say they have a product, and they claim that the product has certain quality, and customers go and buy that product based on that quality. What we're trying to do, let's say we bring those customers, group of them or sample, and then we have come up with facial recognition or just or neuro measuring things that can measure their happiness or their satisfaction with that quality of the product. So if they're happy with that, with the satisfied with the quality of the product, that means that the company wasn't committing fraud in terms of this or deceiving consumers in that term. So we're kind of auditing what the claim of the company in terms of the quality of the product and seeing if that's actually translating into the actual satisfaction of the user of the product. So it's like a auditing the quality of what they claim to be.
Right, right, right.
Okay.
No, I understand. So I'm thinking.
No, I'm trying because it's like, and if they're actually satisfied with the quality, then that's actually going to encourage more transaction, other customers to buy that product because they use that excuse the company has.
Okay. Yeah.
That's
So yeah, it's good. All right. Come on.
It's kind of hard to do it on AIS, but
Number four, right?
one of the one of them, I think one of the examples said that you should use the cognitive and emotional markers when you make decisions. So maybe the only thing we can apply to is maybe internal auditors and see if they're using both kinds of markers
So are these emotional and cognitive markers?
How do they check for emotional markers? I wasn't sure.
That's why. Well, but what you're saying is, so the internal auditor will make decisions based on some sort of markers, and we're going to measure what markers those are and when they occur,
Yeah,
or some.
his decisions, when he made these decisions, did he use both markers or not? Because the optimal point is when he uses both. So
Emotional and cognitive.
cognitive,
Is it? Oh, so that is optimal for.
for making the best decisions.
Yeah. For what was the example in IS?
They didn't have an example. They just said that that how simple emotional cues can simplify complex and uncertain decisions. So
Oh, okay. Okay, so they have a complex decision, and we're kind of evaluating how
yeah,
the process.
yeah.
Okay.
We are focused on number 5 is the design of traditional systems. We came up some ideas like use the tools to track the brain activities or track the blood flow to optimizing the design of the operational system, like how to display the auditing information to let the auditors enhance their information process capability, like what color should show for the red flag transaction and in which position of the screen and whether the information should be in the table or in some visualization, use some visualization tools like dashboard like that, and maybe for different auditors they have different reaction to that. And we have another idea is about how whether the incentives or the penalties will let auditors concentrate on the system in the short term or in the long term to track their brain activities. Thank you.
Okay. Thanks.
So we are focusing on the 6 points. Actually, because we just got the paper, we briefly read it, so uh, we think that it's not be used in AIS domain that, like, for example, now we are in a big data area, we adopt auditors are adopting many techniques, data analytics techniques. So when they want to use data analytics, they need to purchase some like software or like any tools. So when when the like auditors they decide which tools they want to purchase, they maybe they want to. So there are like many auditors. They can we can test their brain in that which technique which software they want to actually purchase. So we do not need to vote. The auditor do not need to actually speak. So we just test their brain. So we can test that their like preference on which tools they can buy.
So it seems like in a lot of these settings that you guys have brought up, you could basically put an auditor in there, and it's an accounting problem.
Yes, it's like if we understand correctly, is that the 6 point is regarding like if there is a project or we want to invest it, and if the decision maker system this make a fair decision or not. So this is what we think.
Okay.
Yeah, so we were discussing the possibility of performing remote online audits. So you need to have verification on both ends, so everyone knows that you're sure who they're talking to, and also if you're auditing a system. We did 9, sorry.
Okay.
7.
8, 9, yeah.
No, we did 9. So you should have like retinal scanners and fingerprint scanners to verify the identities of both parties, and you should also have SSL certificates to verify client host connections.
If got analysis and
Right. So you're talking about like biometric verification.
When you talked about what past additional auditing, where the auditor doesn't have to be there in person in the company, right? The auditing via computers, yeah. So the whole idea is connecting the audit past additional audit to the automating with the continuous auditing, everything automating through computers. Sure.
All right. Thanks. Wow. A lot of great ideas, but it was just hard for me to soak it all in all at once with 7 great ideas. We have to decide if you guys are interested, in this area, though, there's a lot of opportunity, right? Okay, so the paper then goes on to talk about, finally, how to make NeuroIS as valid subfield in information systems, and we're not even close to that in accounting. So they point out that these tools should complement, not necessarily replace existing tools, and that the data generated by the tools can be combined with existing data. So I think what they're saying is there's a lot of opportunity to validate, go through the old studies we've already used, maybe validate the measures with these new measures. Of course, this is an IS thing. We're not quite there. We could create a NeuroAIS conference, though, right? That we all attend, and this is to make it more accepted in the field. And of course, these tools cost a lot of money, so we need funding. And if we can appoint editors to our accounting journals that are experts in this area, and also have lots of reviewers in this area, then we can have high-quality research in top journals. So I have this eye tracker, but I forgot a important component. Yeah.
You actually pay $10,000 for it, like it says in the paper?
No, this one costs about $7,000.
Wow.
I didn't pay, the school paid. Well, these companies make very few of these, and they don't sell very many. So in order to operate, they have to charge high prices. So. Yeah, I forgot the power source for the eye tracker. No, I have the Dell charger. So what I can do is show you some. Let me see what I can show you that's on the computer. But I won't be able to do a live interactive demo. Why is this so big? Well, here's the eye tracker. So you wear it like glasses. This particular one, you just kind of wear it, and here's the. This is has a small camera that points right at your pupil, and an infrared light that shines the light that helps pupil detection. So the light that's reflected using this infrared light will help the eye tracker detect your pupil. And I can't believe I forgot the power cord because there was nothing else in the drawer. I have to go find it now. Anyway, so I need one more thing, actually. I have a... Did I put it over here? Yeah. Oh, here's the power cord. Good. I did bring it. So never mind. Looks like we're going to have a live demo. All right. Can I unplug your thing? No? Yeah? All right. So, let's see if it reaches. So this connects the eye tracker to the computer through Ethernet. All right. Okay, reaches, and then this is the eye tracker, and it's really long, so I can walk around the room and use it, but I don't really need that. And it connects to this controller here. All right. Okay. All right. And then this is mini DVI to VGA converter, so I can show you what's on the screen. And sorry, this won't be on Join Me. So I will disconnect this computer and connect this computer. All right. Yeah. All right. And these bad boys fit on over regular glasses if you wear them. Look like this. So now I look smart as you guys. Okay. So if the eye tracker is powered on and connected correctly, then I can start the software. This takes like 12 seconds, maybe 13. Okay. Oh. Okay. Did fail. I think it's because this USB port might not work. But just to double check things, I see activity. Let's try again. Ah, there you go. All right. So right now the camera is pointing into nothing. There's my finger. See? There's my finger. All right. So does anyone want to wear it? All right. Come on up. So put it on over your glasses. All right. So yeah, so there's a clip here. I can clip it onto your collar. Yeah, you guys are like, wow, that clip is amazing.
What do I feel like something?
Okay, so I will have to point this at your eye. Whoops. Where's having trouble? What? You know what? I always do this. I think I'm pointing the light. I need to point the camera at his eye. There we go. There. Is that your eye? It is harder with glasses, I think.
I can take them off.
Okay.
My vision's not that bad.
There. It found your pupil. But yeah. No.
I shouldn't take my glasses off. I can take them off.
All right. Take them off. Take them off. All right. Okay. So let me actually position it so it points up more. Okay. Ah, see? It's not hard to impress you guys. We haven't even done anything yet. All right, so this isn't going to work at all because we can try it. I mean, it works, but what I do next is I calibrate the eye tracker. Okay, so let's pretend you're looking at this computer screen, and this is what we're testing, what you're looking at, okay? So you would, yeah, don't let it get tangled with there. So sit here. Okay. So, I mean, the computer screen's way too low right now. It should be eye level, but we can simulate that just by bending it the right way and creating the correct angle. Okay. So what I'll do is I'll do a 9-point calibration. And what this will do is, so when you calibrate, what you need to do is look at the points on the screen, but don't move your head, okay?
Wait, which points?
They'll appear when I calibrate it. Oh. So you won't move your head. You have to to be stationary the whole time. Yeah. Yeah, so is that better? Okay. All right. once you're calibrated, then it should know where you're looking on the screen after that. Okay, that makes sense? Yeah, and then we'll test the calibration. So 9-point calibration, you just stare at the dots when they appear. What happened? Stay still. Well, look at this. For some reason, you want like a perfect square. It's always tilted. But for some reason, this guy went way, this one. So let's try it one more time, okay? Just do what you did. It seemed to work pretty well. But I could do a shorter calibration maybe. We'll just do 9 again. Okay, you ready? Oh, that was much better. And I don't know why this is happening. Very good. Very nice. Hey, you moved your head? Oh, you can't move your head after the calibration. Now put it back where it was. So let's look. Now look at the middle dot. Look at the middle one. No, the middle one. Come on. It's so hard to do when you're trying to.
Oh, I'm trying to get it to go into that middle one?
Just go in a circle. No, a circle.
Should I stay at the screen or should I go like that?
Look at your bottom left. Okay, you made it there. Okay, this isn't performing as well as it does with my 21-inch monitor. Usually you don't use the laptop. All right, so now what? So now he's got the eye tracker running. So now I can run my experiment, which I don't want you guys to criticize it because I don't really think it's that good. Okay, so before I run the experiment, let me just show you what I had to do. Stay still. Well, let's just run the experiment. Okay, so I have this bat file that just will execute commands when I double click. Okay, so this experiment is basically trying to induce people to manage earnings. So we have this scenario where they're going to be the next the CFO. If they're a good CFO, then they become CEO. So they work for some auto parts or car manufacturer. I have to reread the scenario that I wrote. So let's click to begin the experiment. And so here it's actually it's a little distorted. It should be, imagine a widescreen, and about one third of the screen is this scenario, and 2/3 is this area. And they have different responses they can click on. Okay, and by separating the responses, I can more accurately track what they're looking at because it's not very refined, If I had ABC in this small area, I might not really know what they're looking at because the eye tracker doesn't work that well. But by separating these buttons, so they have to report a profit, expectations and all that stuff. So we ask them, what is the profit you plan on conveying to the shareholders for the current year? And he selects, the highest one because he wants to really impress them. So we give them different ways to manipulate their earnings. And they go through all these different scenarios. And then the eye tracking is done. So you can take it off. So in this experiment, they say, well, here's everything you told them, all right? And here's all your original decisions. If you scroll down, you can reread the scenario and the decisions. Here's a summary of what you did. Here's what you did. Reserved for warranty expense decreased, artificially increased, stuff like that. Now write a 150-word statement to your board of directors about the decisions you made, why you made them, and write it in such a way that you're going to be promoted next year. So you write something, blah, 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 and you submit it, and then you're done. Then you just have to answer these questions, like, is English your first language? This is called this is the post survey for manipulation checks to see if they did things correctly. So we ask them questions about that and so on and so on. Anyway, so after we're done, we collect all the data, and then we can look at the data, and I'll show you what that looks like. Let's see. Data. There you go. Data. All right. So let's pick one. No. Okay. So here's the data set. Here's the data from one eye tracking file. One subject. And I wish I could. Maybe I should zoom out a little. How do I zoom out? Zoom. Control mouse wheel down. Oh, okay. So here are this is what it records. So this is the total amount of time. So each row is one measure, and it lasts 1/60th of a second. So this runs at 60 hertz, 60 measures per second. So it measures your eye 60 times per second. So it gives you an idea of how all these machines work. They measure you, so often. It creates really big data. Okay. So this column shows your X gaze. So on the horizontal axis, where are you looking? On the vertical axis, where are you looking? And then there's the pupil width and the pupil height, and some sort of quality measure. Then there's this one called marker, and this is the field that I use to record my own data. So whenever they press a button, it inserts a button press or whatever text I want. It'll insert in that spot. So I have one called Start Experiment. So this is the row where they press the Start Experiment button. So after this, I know they've started question 1. And then if I look for the next word called button, so this is where they pressed button number 3. And so this is the end of question 1. After this, they've selected number 3. After this, they'd move on to question 2. So everything between the Start Experiment and the button is everything for question 1. Okay? Right. And I know what those mean, right. So this one file has, 18,000 rows. So divide that by 60, and that's how many seconds it is. So 300 seconds, 5 minutes. It's not very long. Maybe that one's short for some reason. Okay. So also what I can do is run this tool. Let's see. is called data analysis. So here I can load an eye tracking file, a data file. We can do the same one I was looking at, 401. And I could analyze the data in a time series like this. I could push play and watch. So it's putting different types of symbols here, and it's marking them on this window right here. So F is these little green spots. Those are called fixations. So they focused on that area for like more than a second. And then S is a saccade. They go from one place to the next place. So it has these other data points. How many fixations, where the fixations are, how many saccades is kind of how much your eye moves. So I can count those, for example, during each question, how many fixations or how many saccades. So when they select a choice where they've decided to manipulate earnings, do they have a high number of fixations or saccades? I could test that, for example. The other nice thing about the data file is it shows that I showed you before. I can calculate the amount of time spent on each question. And what else? Yeah, and the pupil size is probably the best measure that we have using this eye tracker. Actually, this one doesn't work very consistently in tracking where they're looking on the screen, just because slight head movements or tilt or anything can mess up the whole experiment. So next time what I need to do is I need to add something. It's called, I can't remember, it's a correction. So what I can do is I can say after every question, put another point on the screen and recalibrate them on just one point. It's called like a drift correction, or I can't remember. So that's what I was going to do next to improve the accuracy of the eye tracker. Yeah.
So when you use the eye tracker, that the person would activating that is supposed to be stable.
Yeah, they can't move with this one. So yeah, it's really. So there's a better eye tracker that I want, and what it's. Yeah. So with this data we have right now, we're not going to really analyze where they've looked on the screen because it doesn't work that well. Well, what we can do is look at pupil changes in the pupil. We can look at the number of saccades, the number of fixations, and how much time they spend on each question. And that's about it. Yeah. No, I understand. Like an Oculus Rift. Right. Yeah. Well, there are different types of eye trackers. So there's another one that mounts to the bottom of a monitor. And those can also be inaccurate, and they're not as good as at measuring the pupil. They'll lose track of your eye more often. If you turn your head, it doesn't follow you. The camera doesn't follow you. But they have really nice ones now that will track your face and compensate for any movement. So if you move a little, it compensates for that, and it still knows where you're looking on the screen. So there's a nice one out there. It's $40,000, $45,000. So I need to find someone to buy it for me. Not for me, for research. The common good. 45,000. Do you think Caseware Idea would buy something like that for us? They always say they have money and no one applies for it. Caseware? Oh, well. Okay, well, they won't give me 45,000. Okay, so let me just talk to you about some practical things that I had to go through in order to get this data. So first, I had to get the money from. I had to win a grant from Rutgers. This was a Rutgers grant, internal grant. It's for new professors. So I had to win some money. Then I had to work with the administrative assistant in New Brunswick, Dornell. Maybe you guys know her. She helped me get access to the money. You know, she had to set up the accounts and all that stuff. Then I had to create an IRB proposal to get permission to work with human subjects. I had to be trained. Everyone who works on the data has to be trained with the IRB, so you have to think about that. Then every year they want us to renew the IRB, so they send us notice, and we have to send them a short application to tell them, yeah. So for something like this, where there's almost zero risk to the subjects, they didn't put up much of a fight. It takes a minimum. At Rutgers, they only review IRB applications once a month, so you have to time it. So like the third Wednesday or something like that. So you time it so your application is in at the right time, and then it took us maybe 2 months because they always want amendments, and maybe 2 months total for this.
So one of the comment is those of you using the human subject, before you actually doing this, you get a commission from the IRB. And to do that, you usually take 2 or 3 months at least. So you have to apply this first. Then you get a commission, and you're supposed to do your experiment.
Unless you are friends with Alex Sanella, who is a friend of the person that runs the IRB in New Brunswick, in Newark, and you can get some acceleration. But I didn't know that until we tried to do this.
So those of you actually writing a dissertation, you think the passing IRB commission is going to take less than a month. No, it's not. It usually took 2 or 3 months. So you have to plan first. And also, if you're doing during the summertime, you have to add extra months.
That's right. They don't meet in the summer.
Well, that's why it took us so long. It was between November and February, the IRB took vacation.
That's right. They don't meet during Christmas break.
Oh, wow.
So if you're using the same human subject, Alan or Jasmine help show you how to do it.
Okay? Any other questions?